Hello, this is the density lab. What you're going to do is using the Canvas uh, density lab document that's been produced, the page that's been produced, you are going to record the data that I gather today, and you're going to use that data to then write your conclusion, make your graph, etc. if you have a graph, okay? So the first item we're going to be not measuring, but calculating the density of various irregularly shaped objects. And those irregularly shaped objects are such that it's not easy then to like use a ruler or an instrument to measure the length, the width, the height, and so on, so that we can then use math to calculate the volume. Instead, we're going to, because they're irregularly shaped, we're going to use what's called water displacement. So with water displacement, you're going to have two volumes. You're going to have the volume before the object is put in there, and you're going to have the volume after the object is put into the graduated cylinder. Okay, so we're going to use a graduated cylinder. All right, it's a 100 milliliter graduated cylinder. Each tick mark on here is 1 milliliter. Okay, so therefore we can go to a single decimal place with this. We can go to the tenths place because we know to a milliliter accuracy. So then with the additional digit that we need for that estimated digit, it's going to be a 1 decimal measurement. Okay, so with these objects, if we're going to calculate density with each of them, we need to have two measurements. We need a mass, okay, and I've got a digital scale that will measure to 2 decimal places. So you want to make sure that you record the data to 2 decimal places. And then we need to measure the volume of these objects. So we're going to start with, as we do these measurements, we're going to start with marbles, okay? So it doesn't matter how many we begin with, how many we use. In this case, there are 4, okay, but it just needs to be a number of them. We don't need to divide by 4 to figure out the mass, okay? It's mass divided by the volume. So the density of each of these marbles should be the same because they're all made similarly. All right, so I'm going to drop them onto my scale. You're going to write down or type into your data table that you're creating in Canvas 21.04 grams. 21.04 grams. Now we want to get the volume of those 4 marbles, those same 4 marbles. Okay, so I'm going to get me an initial volume of water, and it really doesn't matter how much you start with. You just need enough to cover the marbles and not so much that you go past the 100 milliliter mark. So I'm reading the bottom of the meniscus here. Okay, so the measurement that I have now for my water, my initial volume of water is 46.9 milliliters. Okay, so you need to type that in as your initial volume of your water. Now I'm going to place the marbles in there. I'm going to be careful not to splash because that's going to then change the volume measurement. I'm going to kind of roll them in one at a time. Each one of them occupies and displaces its own volume in the water. And now our new volume is 55.1 milliliters. So that's the mass and the 2 volumes you need to determine the density of glass marbles. Okay, so I will then get ready to start the next one.